Hello everyone. Welcome to our YouTube channel. My channel, in association of Teaching Point. Like, subscribe, comment. Visit our website www.teachingpoint.org.in.
Hello everyone. Class 11th, Chemistry, Chapter 4, Chemical Bonding and Molecular Structure. Topic, Hybridization. Hybridization. Hybridization is defined as the mixing of the atomic orbitals belonging to the same atom but having slightly different energies, in that a redistribution of energy takes place between them, resulting in the formation of an orbital of equal energies and identical shapes. So in hybridization, intermixing of atomic orbitals take place which having approximately similar energies, and the resulting orbital have identical shape and identical energies. So new orbital formed is known as hybrid orbitals. The shape of hybrid orbital is like that of the p orbital, except that the two lobes are unequal in size. Normally, we observe that the p orbital is have identical lobes, okay, but in case of hybrid orbital, one lobe is small opposite to the big lobe on other side. So this is a big lobe, okay, and this big lobe is larger and this is a smaller lobe. So they are not identical. So they are not identical like in p orbital, okay. So one lobe is smaller and another one is bigger in size, okay. So important condition of hybridization: only those orbitals which have approximately equal energies and belonging to the same atom or ion can undergo hybridization. So in the hybridization is takes place only in those orbitals which are belonging to the same atom or ions and having approximately equal energies, okay. Only orbital present in the valence shell of the atom are hybridized. So only those orbitals which are present in the valence shell of an atom are participate in hybridization. Promotion of electron is not essential condition prior to hybridization. It means, so it is not necessary that is electron is promoted before hybridization. It is not necessary that all half-filled orbital must participate in hybridization. Similarly, it is not necessary that only half-filled orbital are participate in hybridization. Even completely filled orbital with slightly different energy can also participate. In a simple way, we can understand both half-filled as well as completely filled orbital can participate in hybridization. Okay, now some salient features of hybridization. The number of hybrid orbital produced is equal to the number of atomic orbital mixed. What does that mean? If there is one s and one p orbital are intermixed, then the number of hybrid orbital must be 2. Okay, so it is the number of hybrid orbital will be always equal to the number of atomic orbital involved. If 2 orbital is involved, then 2 hybrid orbital is formed. If 3 orbital is involved, then 3 hybrid orbital is formed. Okay, now hybridization never takes place in isolated atom, but it take it occur only at the time of bond formation. Okay, so the hybridization takes place only when bond formation takes place. It do not takes place when atom is present at its isolated state. The bigger lobe of the hybrid orbital are always positive, while the smaller lobe is opposite side has a negative sign. Okay, the hybrid orbital are always equivalent in energy and identical in shape or equivalent in shape. So they having the similar energies and similar shapes. Okay, the hybrid orbital form more stable bond than pure atomic orbital. So the bond formed by the hybrid orbital are more stable than that of the pure atomic orbitals. The hybrid orbitals are directed in space in different direction to have minimum repulsion between them. Hence, the type of hybridization indicate the geometry of the molecule. Okay, so they also responsible for the geometry of the molecule. The type of hybridization we will discuss here are: first, sp hybridization; second one is sp2 hybridization; sp3 hybridization; sp3d hybridization; sp3d2 hybridization. Out of these hybridization in this video we will discuss only sp, sp2 and sp3 hybridization. First, we will discuss the sp hybridization, that is also known as diagonal hybridization. Okay, when one s and one p orbital belonging to the same main shell of an atom mixed together to form two new equivalent orbital. That type of hybridization is called sp hybridization or diagonal hybridization. The new orbital formed are called sp hybrid orbital. See here, this is the s orbital. This is a p orbital. They intermix and they give rise to two. This is one and this is two. Two sp hybridized orbital. Okay, okay. Now, each sp hybrid orbital formed has 50% s character and 50% p character. How we will find the percentage of s character? You know, in sp hybridization, one s orbital and one p orbital. Total number of orbital are 2. So percentage of s character will be equal to number of s orbital upon total number of orbital into 100. So number of s orbital are 1, total number of orbital is 2 into 100. So the s character is 50%. Similarly, percentage of p character is number of p orbital upon total number of orbital into 100. That is 1 by 2 into 100. The value comes to be 50%. So we observe there is 50% s character and 50% p character in case of sp hybridization. Okay, now the remaining two p orbital do not participate in hybridization and remain as such. If these are half-filled, they may form bond with other atom having half-filled atomic orbital. As you know, p subshell contain 3 p orbital, that is px, py and pz. Out of these 3p, 1p is participate in hybridization. The remaining 2p orbital are remain as it is. If they are half-filled, they can also form the bond. Okay, for example, BeCl to BeH2 or all compound containing carbon-carbon triple bond are having the sp hybridization. So here we take an example of sp hybridization in which we discuss about the beryllium chloride, that is BeCl2. You know, the atomic number of beryllium is 4. Its electronic configuration is 1s2, 2s2. So 2s2 is a valence shell. So we consider the valence shell. Valence shell is containing 2s as well as 2p subshell. Okay, so this is the ground state. Okay, at ground state, the electron are remain at their original position. Okay, now they reaches to the excited state. In excited state, this electron is jumped to the higher energy shell, subshell, that is in p subshell. So there is one electron in s subshell and one electron in p subshell. So the orbital participate in hybridization is one s orbital and one p orbital. Here one suggests the numeric number. It is not suggest the principal quantum number. It suggests the numeric number. Okay, so there are one s and one p orbital is participate in hybridization. As we can see here, there is one s orbital and there is one p orbital. When they intermix or undergo hybridization, they will form two sp hybridized orbital. I told you na that the number of hybrid orbital are always equal to the number of atomic orbital involved. So there are two atomic orbital involved. One is s and another is p. So the two hybrid orbital are formed. That is one sp orbital and second sp orbital. When they combine, they having the linear geometry like this one, okay, like this, okay, like this. See here again, okay. So this is the bigger lobe and this is the smaller lobe. This is the bigger lobe and this is the smaller lobe. Okay, okay. The Cl, which is having p orbital, are combined to form BeCl2. Okay, okay. Now we'll move to the next type, that is trigonal or sp2 hybridization. Here, when 1s and 2p orbitals of the same shell, here 1 and 2 indicate the number, not the principal quantum number, same shell of an atom mixed to form three new equivalent orbital. The type of hybridization is called sp2 hybridization and trigonal hybridization. In this hybridization, the new orbital formed are called sp2 hybrid orbitals. Okay, all the three hybrid orbital remain in the same plane, making an angle of 120 degree with one another. Okay, here we can observe there is one s orbital and two p orbital is undergo hybridization and they will form three sp2 hybrid orbital, and these sp2 hybrid orbital are arranged themselves in a trigonal shape. Okay, they are present in the same plane and they having an angle of 120 degree. Okay, now here in sp2 hybridization, s character is 33%, whereas p character is 67%. See how we will calculate. There is one s and two p orbital are present. Total number of orbitals are 3. Percentage s character is equal to 1 s orbital and total number of orbitals are 3. So into 100. So calculation comes to be 33%. Similarly, percentage p character will be equal to how many p orbital are there? 2 divided by total number of orbitals are 3 into 100, and the value comes to be 66.66. Okay, the value come to be 66.66 or 67%. Okay, We consider it. Okay, now for example, here the example BF3, BH3, and all kind of compound of carbon containing carbon-carbon double bond are sp2 hybridized. Okay, now here we take an example of BH3 which show sp2 hybridization, which show sp2 hybridization. Here we know boron, which is having the atomic number 5, electronic configuration 1s2, 2s2, 2p, 1. In boron, the 2s is containing 2 electron and p is containing 1 electron. So this is a ground state. Okay, this electron is jumped from 2s to 2p, and this is the excited state. In excited state, we observe there is one s and 2p orbital are involved. The hybridization is known as sp2 hybridization. When they arrange themselves, they will form trigonal shape. Okay, okay. This hydrogen atom, which is spherical in shape, intermix with these three hybrid orbital and will form the SBH3 molecule, which having trigonal planar geometry in which the bond angle is 120 degree. Okay, now tetrahedral or sp3 hybridization, when 1s and 3p orbital belonging to the same shell of an atom mix together to form four new equivalent orbitals. The type of hybridization is called sp3 hybridization or tetrahedral hybridization. The new orbital are called sp3 or tetrahedral orbital or tetrahedral hybrid orbital. Okay, these are directed towards the four corner of a regular tetrahedron to make an angle of 109 degree 28 minute with one another. Here you can observe there is one s 3p orbital. When intermixed, they will give rise to the 4 1 2 3 4 4 sp3 hybridized orbital, which arrange themselves in the form of regular tetrahedron, and this have the tetrahedral geometry. Okay, so here the s character is 25% and p character is 75%. You can observe there is one s and 3p orbital in which the percentage of s character, how we will calculate, the total number of atomic orbital is 4. So s orbital is 1 and total number of atomic orbital is 4 into 100. The value comes to be 25%. The percentage of p character is 3 is the total number of p orbital divided by 4 into 100 is equal to 75%. Okay, okay. Here we take an example of methane. sp3 hybridization in case of methane. You know, atomic number of carbon is 6. Its electronic configuration is 1s2, 2s2, 2p2. So in ground state, we consider only valence shell electrons, and this electron will jump from s subshell to the vacant p orbital. Okay, so now we can observe there are involvement of 1s and 3p orbital to give rise the sp3 hybridization. Okay, so these sp3 hybridized orbital arrange themselves in a tetrahedron shape. When hydrogen atom combine, they will form CH4 molecule. Okay, I hope you are able to understand this video. Thank you. Thanks a lot.
Hello everyone. Welcome to our YouTube channel. My View My Channel, in association of Teaching Point. Like, subscribe, comment. Visit our website www.teachingpoint.org.in.